Hello researcher. The topic of the presentation is Photonic Spin Hall Effect. It is presented by Lokesh Alawat, research scholar at Delhi Technological University. Topics covered in this presentation are meaning of the word photonic spin Hall effect, Hall effect in electronics, illustration of photonic spin Hall effect, meaning of coupling and its various examples, spin orbit coupling in photonic spin Hall effect, linear polarization as a combination of right-hand circularly polarized and left-hand circularly polarized light. Generation of circularly polarized light from a quarter wave plate. Stern-Gerlach experiment and photonic spin Hall effect in layered structure. What is the meaning of the word photonic spin Hall effect? By photonic we mean that there is something related to photon, that is quanta of energy. Just like electron can have spin up or spin down character, similarly light can either be right hand or left hand circularly polarized. In electronics, Hall effect means separation of the charges when magnetic field is applied. It is illustrated that when current is passed through a p-type semiconductor with magnetic field pointing into the plane of the substrate, leads to separation of the charges, and a whole voltage is created between these two separated point charges. Photonic spin Hall effect is a phenomena in which right hand and left hand circularly polarized light splits up perpendicular to the plane of incidence upon interacting with an optical interface, and it is an outcome of light-matter interaction. Spin orbit coupling leads to photonic spin Hall effect. Therefore, we need to understand what is the meaning of coupling. When the behavior of one object affects the behavior of the other, then they are said to be coupled. In the illustrated example, Bob 1 and Bob 2 are coupled through the spring constant K dash. It is also illustrated in their interacting potential by the term K dash x1 x2. Another example of coupling is Coriolis effect. A pseudo force comes into play due to rotation of the earth. An object moving in the northern hemisphere is deflected towards east due to Coriolis force. In this case, there is a coupling between velocity of the object and angular velocity of the earth. Spin orbit coupling leads to splitting in energy levels of an isolated atom. Orbital motion of the electron around the nucleus leads to the production of magnetic field. This magnetic field interacts with the spin of the electron and leads to splitting in the energy levels. The coupling term is directly proportional to the magnitude of the spin and the magnetic field generated due to the orbital motion of the electron. Spin orbit coupling in case of photonic spin Hall effect is illustrated in the following illustration. Upon rotating the frame of reference by an angle theta, leads to the production of opposite phases in right hand and left hand circularly polarized light. In right hand circularly polarized light, the value of sigma, that is spin, is given as +1, whereas in case of left hand circularly polarized light, the value of sigma, that is spin, is given as -1. Therefore, there is a coupling between sigma and theta, where theta is the angle of rotation of the frame, and this coupling leads to the production of Berry phase. In this case, Berry phase is a manifestation of spin orbit coupling. Linear polarization is a combination of right hand and left hand circularly polarized light. Upon superimposing left hand and right hand circularly polarized light having a phase difference of 180 degrees lead to the production of vertical polarization. In this case, the green bob represents the tip of the electric field that survives. upon superimposing left-hand and right-hand circularly polarized light having a phase difference of 180 degrees. Similarly, if we superimpose right-hand and left-hand circularly polarized light having a phase difference 0, then only the horizontal component of the electric field survives. Here, the yellow bob represents the tip of the electric field that survived upon superimposing left-hand and right-hand circularly polarized light having zero phase difference. Why do we get circular polarization from linear polarization? In classical optics, this was done using the quarter wave plate. Quarter wave plate converts a linear polarization into circular polarization. When a randomly polarized light is incident on a polarizer, then the polarizer polarizes the incident randomly polarized light into a linearly polarized light according to the Malus law. When a linearly polarized light is incident on a quarter wave plane, then a phase difference of lambda by 4 is created between the E ray and the O ray. When these E ray and the O ray superimpose, this leads to the creation of circularly polarized light. There is a close resemblance between Stern-Gerlach experiment and photonic spin Hall effect. In this illustration, we have shown the experimental setup of Stern-Gerlach experiment. When a spin-up electron passes through an inhomogeneous magnetic field, then a force acts on this spin-up electron because of the spin of the electron. As the spin-up electron, upon emerging from the inhomogeneous magnetic field, move in the upward direction, therefore a spin-down electron, upon interacting with the inhomogeneous magnetic field, will deviate from its original path and will move in the downward direction. As a result, spin up and spin down electron will be separated by a distance delta on the screen. Gaussian beam have finite beam radius. Therefore, it consists of a number of beam vectors. When a Gaussian beam interacts with an optical structure, it splits up into right-hand and left-hand circularly polarized components perpendicular to the plane of incidence. This splitting occurs due to light-matter interaction. The splitting between right-hand and left-hand circularly polarized component can be modulated by changing the refractive index of any one layer.